So on this odd function, since it's symmetric with respect to the x-axis, if I look at the area between the curve and the x-axis, keep in mind that this side has a positive area and this side has a negative area, but the quantities are the same amount because of the symmetry. So if I add them together from, again, and I'm doing from negative a to a, notice I marked it on the graph. This is an A over here, even though it might not look like it. I will fix that. Is that those two quantities will then in fact cancel each other out because of their opposite signs. Versus on the even function, if I look at the area to the left, now this is all negative area, but if I split it up and think about the symmetry of the graph, the area to the left of the y-axis and the area to the right of the y-axis are identical, again because of the symmetry. So what I could do is just find it from 0 to a and then double it. So it would look like that. Alright, so looking at the examples, I know in this first one I can't take the antiderivative of a fraction, but I can split that fraction. So I'm going to separate it. And then I can, of course, rewrite each piece. Pause the video and see if you can do it yourself. Hopefully that's what yours looks like. And then I am ready to take the antiderivative. Pause the video, do it yourself. And it should look like that. And then we put a little bar on here so that we can carry the boundaries along with the problem. And then I'm going to simplify. Pause the video, see if you can do that by yourself. Hopefully it looks like that. So now I'm ready to plug in. Remember, I'm going to start with 4, and I'm going to do f of 4 minus f of 1. And I could write this all out horizontally. I just am happening to stack it, partly because I didn't have enough room to go horizontally with it. But I also like the outcome of the vertical stack, because what you'll probably notice right away is that these c's, when I subtract, are always going to cancel each other out. And so now this quantity up here becomes 16/3. This quantity here becomes 8. Remember, I'm subtracting. This quantity down here is 2/3. And this quantity here is 4. And I'm going to have 16/3 minus 24/3. So that's negative 8/3 minus 2/3 minus 12/3 is negative 10/3. And then of course I'll change the signs on those. So I get a final value of 2/3. And you just used the first fundamental theorem of calculus. Let's do it again. So on this one, I already have two individual terms. So when I take the antiderivative, I'll get 2x. And then the derivative of cosecant is negative cotangent. So I would be doing, I already had a minus, and then a negative is going to turn that into a positive. And again, I'd have a plus c here, although I know that when I start plugging in, the two plus c's are going to cancel each other out. So oftentimes I'll get so I don't even write this on here anymore because I know it's going to cancel out every single time. So now remember, I'm plugging this in first. Top one goes in first. Pause the video, see if you can get it. Hopefully you got it all substituted in correctly. Don't forget that you need parentheses after the subtraction sign. Now evaluate. And I hope your answer matches mine. See you in the next video, kids.